Okay, welcome. This will be talk a little bit about app weather right now. I wanted to just give you a quick overview of some of the things we're going to begin in each chapter. Basically, first, we're going to talk a little bit in this chapter about what is weather. And we're going to begin to look at some weather maps. You're going to be looking at them a lot in the investigations manual. So let's just begin with one. What I'm showing you here is a weather map with pressures, such as these lines right here. These are lines of equal pressure, they're isobars. This is a cold front. The triangles indicate cold air advancing. So, Ohio right now, and this is early Friday afternoon, late Friday morning time frame. We would have a weak low and lower pressure. So there might be some bad weather, there may not be, but you also would have cooler air on the northern half of Ohio and warmer air in the southern half. So that is looking at just a quick look at the weather maps here. And as part of this, I just wanted to show you that there's other things going on. We use a lot of tools. All of these plots on here are stations that take an observation. What's an observation, you would ask? Well, if you walked outside your dorm room or just outside anywhere and told me what the weather was, you'd probably tell me what the temperature was. You might tell me what clouds you might have in the sky. Is there a wind hitting you in the face or behind you? How strong is that wind? Is it dry air you're feeling? In other words, boy, is it really a muggy, hot, humid summer day, or is it, hey, not too bad today? Oh, is it raining? All of that kind of information is plotted on a weather map. So we're going to be talking about those and how to read these weather maps. We have different tools to observe as well. And one of those, for example, is radar. So here is a radar image across just north of Chicago. There's some light rain up there. Just north of Milwaukee here and across the Great Lake, Michigan there. So all of this is how we look at the weather. We want to know what's going on. So now let's look a little bit into a little presentation here. We'll do a from the beginning here. We're going to just talk about it. So what are some of the basic characteristics of the atmosphere and weather? So weather is what's happening now. Okay, if I told you to observe the weather, you walked outside and told me what's happening now, that would be the weather. However, if you had walked out 20 minutes earlier, that would have been the weather 20 minutes ago. Weather is changing all the time. So if I am going to describe the weather, I need to have it at all the same exact moment in time. That's why that weather map I just showed you, all those stations were at exactly the same time. Climate is basically an average of weather over longer periods. And climatology is looking at all the different things that impact the climate. Basically in other words, we're going to tell you if you live in Ohio, you're not going to get down to 50 below zero or 60 below zero. That would be climate dictating that to you. Here are time zones. The Weather Service uses Greenwich Mean Time. Greenwich Mean Time is Greenwich, England. The time at Greenwich, England. That map you just saw drawn said 15Z. So that meant it was 3 o'clock in the afternoon at Greenwich, England. Well, guess what? The time difference between there and the eastern U.S. is 5 hours. So that map that you just saw at Greenwich, England, would be 5 hours earlier as far as the time goes. But they're all exactly the same moment in time, just a different local time. That's why we use one standard time for the whole globe. Here we just looked also at this. High pressures, low pressures, cold fronts, and a little bit of air masses. Air masses basically are the same air over a large quantity of the air of a region. For example, if all the air over Canada was cold and dry, that would be an air mass. By the same token, if you're out in the middle of the subtropical Atlantic, down along the equator, maybe you have all humid, hot air. That's an air mass. The dividing lines are the fronts. You need to know the wind direction around highs and lows. Around the high pressure system, the winds tend to blow out away from the high and they're blow clockwise. Low pressure, they're blowing inward towards the low and they're going counterclockwise. We just talked about air masses being over a large volume. Interestingly, warm air, it doesn't weigh as much as cold air. Well, that means it kind of floats over top of cold air. So if I have a warm front approaching you, the warm air is actually going to come in first, aloft, before it actually reaches you at the ground. So if you were on a mountain, you may actually feel the air getting warmer. And I have seen this sometimes on mountaintops, even 3,000-4,000 foot mountains, where the air all of a sudden starts, the warm air has arrived there, and the temperature might go from 20 degrees to 45 degrees. But down in that valley, it's still 20. Cold fronts, cold air is advancing. Cold air is a lot heavier, so it tends to push the air up faster. That's why we get more thunderstorms with it. When I was describing the state of the atmosphere, these are all things we talked about right there. Clouds. Clouds can tell you a lot about what's going on. First off, the higher up in the atmosphere, the air keeps getting colder and colder in the troposphere, which is where we live. So, and where all the weather occurs. So, if the air gets colder, eventually it gets cold enough that they become ice. That's why you see the wispy shapes on cirrus clouds. Lower, they're more water, liquid. So both of these, one is ice crystals, one is liquid, and they're what makes the cloud look different. Fog is just a cloud in contact with the ground. Stratiform clouds, they're kind of a layer. They all have about the same layer to them, look just very flat. And they can be at different altitudes in the atmosphere. Wind blows these clouds along. So if the wind's blowing in from a different direction, stratiform clouds can move different directions. Puffy clouds, cumulus clouds, they kind of build up, and if you get enough of them building together, you get cumulonimbus, and that causes your thunderstorms. So that is what I wanted to discuss in this first one, just giving you an idea of what you're getting into. So I hope you got a little bit out of that. Let me know if you have any questions.